Arrhenius equation. In this video, I'm going to be discussing about Arrhenius equation, its mathematical representation and its graphs, including previous JEE and NEET questions based on Arrhenius equation. This more important concept to 2019 they're asked, as well as 20 they're asking, even they asked previous also. Concept is same, they are repeating number of times questions, number of times. You will see that one. How many times they repeated that questions based on Arrhenius equation. Similar questions they given or not. Everything we can see end of this video. Okay. So mainly this equation gives relationship between rate constant, absolute temperature, and activation energy. We know that one by changing temperature, rate of reaction going to be increases. So what is the quantitative relationship? How to calculate? By changing temperature, rate constant also will be changed. How to calculate? How much increases? How much decreases? That things we are going to be calculate. That relationship, which is again quantitative relationship, they're given by Arrhenius. That equation is K equal to A into minus EA by RT. We know that simply temperature increases, rate of reaction, rate constant increases. Our rate constant can depends upon temperature. Okay, by changing temperature, rate constant also will be changed. But how much change? How to calculate that change? That relation given by Arrhenius equation. So this is K is the rate constant here, and A is the, here they mentioned this as it is NCERT book, we copied here. A is the Arrhenius factor or the frequency factor. It is also called pre-exponential factor. It is a constant specific to a particular reaction. Okay, I mean that depends upon reaction. Different reactions have different A values. R is the universal gas constant, and T is the temperature, absolute temperature. EA is the activation energy. EA is the activation energy. So you can see here activation energy definition also. The energy required to form this intermediate called activated complex. So is known as activation energy, nothing here. So we are going to be learn that is, this is the way E, this is reaction coordinate. This is reactant convert into product. So the amount of minimum energy required, this is the threshold energy. We'll discuss clearly this is later another video. The amount of energy required to reach threshold energy, the minimum energy required. This is we call activated complex. Okay, here I am showing activated complex C. You can think that one. The amount of energy required to reach activated complex from reactant to activated complex. That's we called activation energy. If this reaction is forward reaction, you can take it EAF. If there is backward reaction, you may can take it EAF backward reaction. Fine. So you can apply mathematical relations here. You can see one by one. So you can take ln both side, ln k equal to ln a minus EA by RT. I can write EA by RT nothing but 1 by T. So here, this is the graph they're asking number of times. Number of times they ask that one. What is the graph? ln k versus 1 by T. Keep in mind, they are giving questions directly by T. Directly they're given T. Or 1 by T or T inverse also you can take it. Then can you try it? This is the way how to get it. This is the intercept ln A and slope equal to nothing but tan theta minus EA by R. So very simple this is. Y equal to mx. So you can compare, this is y, this is c, this is mx. If you are taking logarithms in terms of log, this is ln. You can consider log also. Log, if you are taking log, In place of, I think you can write it ln equal to log base 10, okay, into 2.303. You can write ln equal to 2.303 into log base 10. So in place of ln, I can substitute that one. So what will get, you can write. So 2.303 log k equal to 2.303 log a minus a by 2, sorry, a by r into 1 by t. So I am dividing both sides 2.303 with respect to 2.303. So what we will get, you can see here. So 2.303 log k 2.303 equal to 2.303 log a by 2.303 minus a by 2.303 into r to 1 by t. So after solving this is finally we can get it answer log k equal to log a minus a by 2.303 into r into 1 by t. So again you can draw graph with respect to log also. Log k versus 1 by t. So you can get it graph. Clear? This is the intercept log a and slope equal to again tan theta. You can write here minus ea by 2.303 r. Actually in examination they will provide slope value, then they can ask activation energy also. That is a way also you have to keep in mind. In examination they will provide some slope value, maybe minus 30, minus 40, like that. Then you need to calculate ea value. Okay, this is at particular temperature we are calculating. Suppose we are calculating at two different temperatures. That's our target. How they're changing with respect to temperature, rate constant. This NCERT book also they mention very clearly. So I'm going to be calculate here at different temperatures. I'm assuming here at different temperatures also we are assuming that one. Okay, assuming that one activation energy is constant as well as A also constant at different temperatures. So at temperature T1 I can write here log K1 equal to log A minus EA by 2.303 R into 1 by T1. This is at temperature T1 at T1 temperature. Log K2 log A minus A by 2.303 R into 1 by T2. This is at T2 temperature. So you can assume this is equation 1 and 2. I am subtracting from 2 to 1. You can subtract 2 minus 1. You can get, I think so, log A by B form. Okay, log A by B equal to log A minus log B, like that. So by rearranging this is, you can get it here ultimately log K2 by K1 equal to, anyway A will be cancelled, EA by 2.303 into R 1 by T1 minus 1 by T2. Actually 1 by T2 minus T1 will get, but minus is there, that minus we are inversing, that is okay. Finally we'll get this the expression. So at different temperatures, T should be in kelvins we are taking here, we are getting K value. K2 is the temperature T2, K1 is the temperature T1. So we are assuming here activation energy doesn't change with respect to temperature. Maybe in terms of ln also you can write it. If you write ln K2 by K1 equal to, so EA by R 1 by T1 minus 1 by T2. You make and apply LCM here. Understood? So rate constant, it will change by using temperature. Okay. So that's we seen that one here. So generally, for general reactions, I'm writing are common reactions. Even you make and take it rate of reaction also, as well as rate constant also. So I'm giving here a rate versus temperature also we can discuss. A rate versus temperature, rate and temperature. So you can expect this the graph. This is for general reactions. Or normal reactions you can take it. And again another case, explosive reactions, rate versus temperature. This is for explosive reactions. Even rate constant also you can take it, doesn't matter. Next one, at biological reactions, rate versus temperature. So initially rate of the reaction increases, that reaches some peak, then they fall down. This is for biological reactions. The only one reaction you have, that one, by increasing temperature, rate of reaction going to be decreases or different, so that's showing different way. That's the reaction I'm providing here, only one reaction. That's actually rate versus temperature, that's showing like this. By increasing temperature, rate of reaction decreases. This is 2NO plus O2 gives rise to NO2. This is the only reaction exception. Okay. And rate of oxidation of carbon. Okay, rate of reaction with respect to temperature, oxidation of carbon. Next, rate versus temperature. This is oxidation of carbon. Clear? So we'll see any questions based on this, any previous questions is there directly. So what type of question they can ask, can analyze before solving. Mostly here They may can say calculate the Arrhenius parameter by giving remaining values. Here one more point, suppose e power minus Ea by RT become 1 total value. In that cases, I can get it K equal to A. When we are getting K equal to A for first order reaction, suppose, okay, if it follows first order reaction, then K units is second inverse. Second inverse is the frequency units. That is the reason they are taking frequency factor. When this whole part is become 1, then they are going to be take it frequency factor. Clear? So we'll try some questions here. This is 2003 NEET question. May can see, I think so, very clearly are able to see that one. Direct questions, they are not asking any difficult question. The temperature depends on the rate constant K of chemical reaction is written in terms of Arrhenius equation. This is they given. Then they're asking graph. Okay, which one you have graphs? Log K versus 1 by T or ln versus 1 by T, but not log T. That is, keep in mind. Is it correct or wrong? If you want, you can check it. So we given graphs. You can see here I given all the graphs. Here log K versus 1 by T I given, or ln K versus 1 by T. Okay, so your answer should be C. Now we can try it another question which is related to this one. Yeah, one more. 14th question, 2012. Activation energy EA and rate constant different temperatures. What's the graph given? ln K2 by K1, EA by R, 1 by T1 minus 1 by T2. Okay. If they're keeping minus means we should not be right here. They're keeping minus means we can't write. You can see here. ln K2 by K1, EA by R, 1 by T1 minus 1 by T2. If you are keeping minus means you have to write 1 by T2 minus 1 by T1. But again, very clearly this is the expression. So direct formula based questions, you can get it. Direct formula based questions. So you don't want thing. If you know that Arrhenius equation, you can get it. See, still we got 2 times this question. Okay. Now we can see 7th question, 2015 they given. Same question, ln K versus 1 by T. So option A is again answer. If you know concept, you can get it very fast, all these things. Still some question, theoretical questions also is there. Still theoretical questions. So you make and write. Now we can see one JEE question if possibility is there. These are 2019 JEE questions. Yes, you can see 24th question. Consider the given plots for reaction obeying Arrhenius equation with the temperature range K and EA for rate constant and activation energy they given. So higher the activation energy, lower the rate constant, sir. or rate of reaction also you can say that word. We know that one log of K2 by K1. Okay, EA by 2.303, 1 by T1 minus 1 by T2. So you can see simple way that ratio will be more, but K will be decreases with activation energy. Ratio will be more when activation energy is more, means change is more. For example, here initially at activation energy is 100 is there. We can take it that is simple way you can take it. You understand? More the activation energy means less the rate of the reaction indirectly. So here suppose 20 joules is the activation energy. Next case we have only 10 joules. 10 joules means they can easily reach activation energy 10, they can convert into product. So higher the activation energy, lower the rate constant or rate of reaction also lower that is. And by increasing temperature anyway, rate constant going to be increases. This is not the 1 by t, please keep in mind, this is not the lnk and 1 by t graph. Okay, that increases exponentially, that increases exponentially. So both correct. By increasing EA value, this is K2 by K1, two ratios different. Then they're asking single, they're asking different. Clear? So whenever activation energy higher, rate of reaction is less. So that's the graph correct. And temperature increases, rate constant increases exponentially. That's that one K equal to A into e power minus EA by RT. So simple thing. Correct. Both. Okay. So I can say both options correct. So one more you can see that one here 26. If reaction follows the Arrhenius equation, all these questions are 2019 January questions. If a reaction follows the Arrhenius equation, the plot ln k versus 1 by RT. So we given graph can take it ln k equal to ln A minus EA by RT, but they are taking 1 by RT. This is both are correct. They are drawing graph y equal to this is CMX. So what is the slope equal to here? Slope equal to if you draw on ln k versus 1 by RT, anyway we will get like this. This is intercept ln A and slope equal to minus ES. So they given already in terms of my minus unit. Okay. So minus y slope equal to equal to EA. So I think so will be cancelled. Then activation energy should be y. Activation energy should be y. So these are the Arrhenius equation based questions. Still, if you see previous questions, advanced questions also is there. Make and calculate. Thank you. Thank you very much. We'll discuss next video collision theory also. Thank you. Thank you very much.